So today you were learning about direct and inverse variation. If you remember at the start of the year, like before you learned how to graph linear equations, you learned about the direct variations and how to graph them. So you're going to do a little more with the direct variations, and you're also learning about inverse variations also. So like this says at the top, so some situations in which y increases as x increases, those are called direct variations. And so those are the ones you learned about before. And so if they do vary directly, then you can represent it by the relationship of y equals kx. And then, so in this chart to the left here, so if you notice, so as the gear ratio is going down here, then the rate is going up. So for this here, and also if you look here, so if you multiply each of these together, you're going to happen to get the same thing each time. So that means we'll talk more about it, but for this table here, so these would be inversely related or inversely proportional, and so that would be an inverse variation for that one then. So like I said, we're pretty much like going to compare them and work stuff out here. So for the direct variation, so your equation would be y equals kx. And so remember k, this is called your constant of variation. And so for the direct variation, so these lines will always pass through the origin. So kind of like this line here. So it'll be linear. And the inverse variation, so these equations are xy equals k. And then this is what your graph will look like here. Or sometimes you may have like two different parts. If it's like this, it could that's supposed to look more like this. So you could also have a graph. You could have one of these in like two opposite quadrants. So you could have something kind of like this, and then something like this, and this would still be inverse here. So you could have something in the other opposite quadrant there. So that'd still be inverse. And then so if you have a set of ordered pairs, you can use this to help you, or if you're dealing with a table. So you can remember the D's go together. So direct divide, which means if you're dealing with a set of ordered pairs or a table like this here, if you divide, so when you divide, you'll have to divide the y by the x. So the D's go together, like I said. So direct divide. So I'll show you once you get to it. But so direct divide, which means your other two go together. So the opposite of that. So the opposite of direct would be inverse then. And the opposite of divide would be multiply. So direct divide and then inverse multiply. And then there you would multiply the x and the y together. It doesn't really matter the order. This one, you just have to divide the y by the x there. So this, like I said, this will help with your tables and with a set of ordered pairs, which means for these tables here, so it's asked you to determine if your inverse or direct variation exists, and then if so, determine your constant of proportionality, constant of variation. So constant of variation or proportionality, that's just asking for whatever your k value would be. So for these, so I would go through, so you can figure out if it's direct or inverse. If you want to check direct first, so you can divide them. So you can divide the y by the x, and you'll have to get the same thing the whole way through. So for this one here, if you divide the y by the x here, 24 divided by 1 would be 24. Because you need to divide the whole way through. 12 divided by 2 would be 6. And then 8 divided by 3 would be like 2.6 repeating or 8/3. But for this to be a direct, you have to get the same thing the whole way through. So you're not getting the same thing. So you can check to see if when you multiply the x times the y, you do get the same thing because you tried dividing and that didn't work. So you can multiply the x and y together. So 1 times 24 would be 24. 2 times 12 would be 24 again. 3 times 8 would be 24. And then 4 times 6 would be 24. So you got the same number each time when you multiplied here. So since you got the same number each time, this will have to be inverse because you multiplied and got the same number the whole way through the chart. So this will be inverse here then. And then for the second part here, it's asking you the constant of proportionality, which is also called the constant of variation. Pretty much it's asking you what your K value would be, or what value you got the whole way through when you went through and got the same number when you multiply these together. So here, constant of proportionality here would be 24. So your K would be 24 because that's what you got each time when you did that there. And then so that was inverse. This one will probably be direct. So if you want to check to direct divide, the d's go together. Just make sure when you do divide, you divide y by x instead of the other way around. So you can divide that and make sure you have the same thing. So for this, so 6 divided by 2 here. So you're dividing. Just make sure now you're doing that order. Okay, so 6 divided by 2, that'd be 3. 15 divided by 5 would be 3. 24 divided by 8 will be 3 also. And then 33 divided by 11 will be 3. So you got 3 the whole way through when you divided. So this has to be direct then. And then this is also asking you what your K would be here, what the constant of proportionality would be, your constant of variation. So your K is going to be 3. And there's also another part to your answer too. The last part, this wants you to write your equation. So I'll go back and do it for the one right here. But let's do this one that we're on. So it's y equals kx. You figured out your k was 3, so you can just sub 3 right in there. So that means this equation y equals 3x is all. Which means for this one here, so we already figured out our k was 23 and it was inverse. So you can sub your k right in here that you got. So this will be xy equals 24. Because you can just have the 24 in there since you know the k was 24. And those are your equations there. And just make sure, so you know, these little shortcuts, direct divide and inverse multiply, those help you with a set of points or table. They don't help you with your equations. Because if you look here, this is still multiplying here, and this is also multiplying. So this is mainly just to help, like a shortcut way to help you with the tables. But it won't help you with the equations. You'll have to see which it is, or which you can rewrite there to look like the form. So for this one here, so this wants you to identify all equations that represent inverse variation. So remember, so for the inverse, that'll be xy equals k. So so some of these may already be in the right form, and you'll have to see if you can rewrite the others. Although if they're direct, there's no way they could be inverse. So if you look right off, there is one of these that's already in the right form. It'll be this one because you have xy equals 7. So pretty much your k is 7 there, your constant of proportionality. So you know this will be an answer. And then you can check the others. For this, you have y equals negative 2x. You could try and get your variables on the same side like they have here, and you can divide by x. Although, if you look here, this is y equals kx. This is already direct, which means there's no way that it could be inverse. I mean, you could divide by x here because you'd have negative 2 equals y over x, and you would want to be multiplied there. So that couldn't work unless it was direct instead. And then for this first one here, so you have y equals 5x plus 4. This one here, this is like a linear equation slope intercept form. This isn't even direct either. It would be direct if it didn't have the plus 4. There's no way that you could get this to look like this. Plus, this is here, and even if the 4 wasn't there, then it'd be direct instead. So if you try this one here, I'm going to write it out first over here. Because you may be able to rewrite this to look like this, your equation here. So I would try and cancel out your fraction first to make this easier. So they're dividing by x, so you can multiply by x on both sides. So these will cancel. So you'll have xy 4. So here, so you have x, y equals k. So your k will be 4 here. So this will be your other answer here. So it'll be that one and this one. They'll be inverse there. And then, so for the next one, so you have this table here. So this says the table shows that y varies directly as x. What are the missing values going to be here? For this one, so if you remember, so your d's go together. So it's direct divide. I'm just writing this because this will help you with the tables and a set of ordered pairs also. Just make sure when you're dividing them, so you're doing y divided by x. So I would use either this one here or this one to help you out because you can't use 18 and 6 because that's what you're trying to find here, those values that correspond with those. So you can figure out what your k is going to be if you want here because you can divide the 24 by 4, which if you do, you'll get 6 for that one. And then negative 12 divided by negative 2 would also be 6. So pretty much you're figuring out what this value is going to be. So when you do 18 divided by that, you do get 6 because that has to be a 6 also. So you can figure out 18 divided by what would be 6. So if you do, then that'd be 3 because 18 divided by 3 would be 6 then, like you wanted. And then for this one, you're trying to get 6 when you divide. So you're figuring out what divided by 6 would be 6. So that'd have to be 36 then because 36 divided by 6 would be 6 there. And then you'll have 6 the whole way through as the k like you wanted. So yeah, 36 will be there and then your 3 is going to be there. So your k for that one is a 6. For the next one here, so it says the painting contractor determines the average amount of time needed to paint a house. When 2 painters are used, it takes 20 hours to paint the exterior of a house. When 6 painters are used, it takes 6 2/3 hours to paint the exterior of the house. Let P represent the number of painters and H represent the amount of time. Which statement's true about this relationship? So I would first figure out whether this is direct or inverse to start. So you can figure out when you multiply these two together, whether you get the same thing or when you divide. So if you divide the 20 by the 2, if you divide this by this, you'll get 10. But if you divide 6 2/3 by 6, you wouldn't get 10 there. So you tried dividing and you didn't get the same thing. So it wouldn't be direct, but then you'll have to try and multiply the 2 together to see if you get the same thing. So you can try and do 2 times 20, so you can multiply them there then. So if you do 2 times 20, you'll get 40 there. And then you can make sure you get the same thing when you multiply 6 and then 6 2/3. So if you multiply those two, that'd be 40 also. So you multiplied and got the same thing here. So the D's go together. So direct divide and then inverse multiply. So you multiply there. So this has to be inverse for this one then. So you can eliminate the first two here because we know this is going to be inverse. And if you look here, so it says 10 times the painters equals the hours. And then for D, it says the painters times the hours would be 40. So you know this has to be D here because you multiplied the painters times the hours and you got 40 here. 10 times the painters, 10 times 2 would be 20, but 10 times 6 wouldn't be 6 2/3. So plus this equation matches direct variation instead. So this will be D there. And plus another way to tell this here, so you know that the more painters you have, the less time it would take, and then the less painters you have, the more time it would take. So you would also know that it would take them, that this would be an inverse variation automatically. And then, so for this next set of questions here, so this wants you to determine whether each scenario is a direct inverse, direct variation, or inverse variation. So you're trying to figure out whether they're like both increasing or whether one's increasing and one's decreasing. So this is the amount of money I make after how many hours I work. So the more money you make or the more hours you work, the more money you make. These would both be going up at the same rate. Plus this depends on this here. So this will be direct then. Because the more you work, the more you'll get paid. And the less you work, the less you get paid. And then for the next one, so it says the number of people I invite to the bowling party and the number of games each of them will play. I'll draw an arrow here. So the more people you invite, then it's more people that are trying to squeeze on each of the lanes. So they're gonna be playing less games. So that'd be inverse then. Because if you invite less people, they'll play more games. And if you invite more people, they'll play less games there. And then for the next one here, so it says the number of tickets Allie can buy for the choir concert and the cost of the ticket. I'll start down here and then go there. So the cost of the ticket, so the more that costs, so she has like a set amount of money. So the more the ticket costs, then the number of tickets she could buy, so the less she could buy, which means as the cost of the ticket decreases, then the more she could get. So they're going two different directions there. So this would be inverse then. And then the amount of money earned for the cans here cycled. So for this one, so the more you collect, then the more you're gonna, or the more, oh, this should be here first. The more you collect for your cycle, then the more money you'll earn for that. So this will be direct then, kind of like the first one. And then for your next question here, so this says the number of calories C burned while walking is directly proportional to the distance D a person walks. Tom burned 180 calories walking a distance of 2 miles. Which equation represents this relationship? So for this one here, so this says that it's directly proportional. So since it says directly proportional, that means, it's going to be direct variation since it says that there. So if it's direct variation, it'd be it'd be direct, so like y equals kx. Here they're using other variables, but that's fine. So here, so it says the number of calories burned, so I'll use their variable. So calories burned, and it says it's directly proportional, so that's where the k is going, so it'd be k. So directly proportional with the distance d. And then you may notice the answer here, but I would sub in these two, that way you can figure out what the k is going to be. So the 180 calories, so that's C, so it can go in here. And the K is what you're finding. So it'd be 2 times the D, which is the distance there. And then, hold on, that was just a D. Hold on, I put them in the wrong spot. This will be K times 2, sorry. Okay, because you're finding K. And then you'll solve for K here, so you can divide by 2. So your K would be 90 then. So now you have the K is 90, so that means it'll either be B or C here. And so pretty much you can just sub 90 right into your equation there. So BC equals 90D. So that'd be your equation. So it'd be B. And then, so if this says this was inversely proportional here, you could do xy equals k and then do the same thing there. Just sub in what you know, and then you can write the equation then. For your next one here, so it says the money Mr. Jared earns varies directly with the number of haircuts he gives. He earns $15 for 5 haircuts, which graph represents his earnings for the job. So this says it's varies directly, which means, this is going to have to pass through the origin, which means there's no, it could be this one here. And then, so I will go ahead and figure out like what the K is going to be here, which is like the price per haircut. So it says he's earning $15 for 5 haircuts. So you'll divide the 15 by the 5 there. So if you do, then it'd be $3 per haircut. And then you can just figure out where your graph matches up. This one here, so 0 haircuts cost $0. This says 1 haircut costs $2, so this couldn't work. For the next one here, so this 0 haircuts be $0 again, since it starts at the origin. But then, so one haircut is between 2 and 4. So this is there, which means 2 haircuts would be $6 and so on. So it'll be this one then. And this one's going up too much there. That's too steep. And then for this last one here, so this asks you, says, given the set of ordered pairs, select 3 points that will create a direct variation relation. So for this one here, so the D's go together, so direct divide. Okay, so direct divide. Just make sure when you're doing them, so you're dividing the y by the x each time instead of the other order. So pretty much for these, you're going to go through and divide the y by the x on each one. So you can divide the y by the x for each of these here. So for this one, so you'll do 3 divided by the negative 0.4. So if you divide those two, so 3 divided by the negative 4, you'll get negative 0.75 for that one then. And you can do each one. So then you can divide this by this there. So 2 divided by the negative 6 would be negative 0.3 repeating. And then you can divide that by that. So 16 divided by would be 4 for that one. And then you can divide these. So y divided by x, that'd be 4 again. Then you can divide your y by the x here. So 8 divided by the negative 2, so that'd be 4 again. And then 9 divided by the 3, so that'd be 3. 4 divided by 4 would be 1. And then you can divide these here. So you have negative 12. So pretty much you're figuring out which of these give you the same value, like the same value for k when you do them. So this will have to be, so you got 4 for these 3, so it'd be these 3 then. So it'd be 4, 16, and then this one, and then this one. So if it was asking you which of these would create an inverse relation, so you could just go through and so like inverse multiply. So you multiply the x and the y together each time and see if you get the same thing. So there's a Google form you're doing with more practice on this stuff. I know this is kind of confusing and it's a lot of different things to keep track of. Just let me know if you get stuck and need help with any of it though.